Subtract and add. Let's learn some math. Subtract and add. Let's learn some math. Let's learn some math. Let's learn some math. Let's learn some math. 1 plus 1 equals 2.
We'd like to move on to mapping. I'm sure some of you have read on it. Um, Before we take that, I think we have been learning for some time. Let's refresh our mind a little with this riddle. Why was 6 afraid of 7? I would like us to think about it and share our answer. Interesting. For this one, I'm seeing quite a number of hands raised. Wow. Okay. Okay. Very well. Very well. Very well. Okay, so let's have someone explain. You give me your answer, you explain. Okay, some hands are going down. Okay, Empress has not spoken in the class yet, so let me give the chance to Empress. Empress, what's your solution?
Because 7, 8, 8, 9.
Come again.
7, 8, 9.
Why?
So like 7 has eaten 9, but since it's a math joke, 7 like the number 8, then 9.
Okay, do we agree with her?
Because 7, 8, 9.
Okay, that's fine. That's fine. So like I was saying, this one has become popular. I think one of my class, the first class I used, we got some interesting answers that we could laugh about. Okay. So next time I'll put a challenging riddle, but they are simple as that. So the idea from this particular one is to let you know that mathematics is not really so huge. You know, those who have never heard this riddle before will go thinking about calculation and a whole lot. But then it's as simple as just identifying a certain pattern. So you have 7, the numbers 7, 8, and 9. When you read them in English language, kind of, the sound, let's say the sound, it sounds like 7, 8, 9. Now, mapping is also a relation, but this one maps elements in one set to a unique element in another set. And you agree with me that this definition is very similar to the definition of a function. Do we all agree?
Yes.
Okay. So that means that we can say mapping is the same as a function. From the definition we have, we can say that a one-to-one relation and many-to-one relation are all mappings. Just as we saw for functions, we write something like an equation, or let me say functions are written in equation forms. Mappings are also typically illustrated using a diagram. And this is how it usually looks like. I'm very sure we have seen this before at the basic school level. Good. So
Yeah.
this typically tells us that we are relating members in the domain to members in the codomain, where we still have our x and y, but in this case, turned in the top-down approach, unlike the left-right approach that we saw earlier. So it's still the same thing. It can be in the left-right or the top-down approach. So from here, we can say that the values of x forms the domain. Do we agree with that? And then the values of y forms the range or the codomain. So for every mapping, there is a rule. And the rule is what links each element in the domain to a particular value in the range or the codomain. So we are looking at the fact that the arrows here are pointing from x to y, which means something is happening to the values of x, which is producing the values of y. What is actually happening is what we call the rule. When we come to functions, that rule can be described as a function because it is what is relating the domain to the codomain. I hope you understand. Okay, very well. So we have so much knowledge about domains and codomains so far. So we are going to pay attention to the rules, especially how to come about the rules. So for this particular lesson, we are going to look at two rules or two approaches to come up with the rules. And these are for linear mappings and exponential mappings. Let's begin with linear mapping. When we say linear, I'm sure we have come across the word linear. What does linear means? Okay, Napari.
Linear is something that goes in a straight line or path.
Okay, straight line or a path. Very well. Any other person? So, Christine, what do you think about linear? When we say linear, what does it mean?
A straight line.
A straight line. Very well. So, we are expecting that a linear mapping will behave like a straight line or will give us a sense of something that is happening in a straight path. So, we say that a mapping is said to be linear if the differences between the consecutive elements in both the domain and the codomain is constant. Okay, let me transition smoothly. So we started by saying linear means a straight line. Now, whenever we plot on a graph the values of a mapping, that is in this case the x and the y, just as you did in the basic school, and you join the points, you end up getting a straight line. Okay, so those pair of values for x and y can be described as a mapping that is linear because we have x corresponding to y, but when we graph it, we get a straight line. And this is as a result of the fact that when you check the differences between the consecutive elements in the domain, the first value and the second value, you will notice a constant difference. We shall take a typical example for you to understand very well. So you will notice a constant difference between the consecutive elements or members in the domain. When you do same for the codomain too, you get a constant value. We see the mapping we have here. We are saying that this particular mapping is a linear mapping because when we examine the members in the domain, okay, when we pay attention to the members in the domain, you see we have 1 here, followed by 2, 3, 4, 5. We notice that the difference between 1 and 2, what would be the difference between 1 and 2?
1.
1. And the difference between 2 and 3? 1 as well. And you notice that that continues. When you check the difference between these consecutive numbers, you get a common difference. You have 1, 1, 1, 1 throughout. When we do same for the codomain, you have 1 and 3. What's the difference?
2.
2. When we do same for the 3 and the 5, what's the difference?
2.
2 as well, and it continues. So we say this particular mapping is linear. Okay, so that is what we use to determine if a mapping is linear. Can I have a guess for the rule that is linking this mapping? Can we guess? Okay, I see Amankwa saying x plus 2. So this is a guess. You don't necessarily need to get it right because we shall look at how to come about the rule all the time. Okay, okay. So we have 1x plus 2 in Nkrumah, and then Jelisa also commented. So you are all right. Would this be a linear mapping and why? Okay, Serena.
It's a linear mapping because the difference between the consecutive elements in x and y are constant.
Okay, Caleb.
I agree with what she said.
Okay. So when we look at the difference between the members of the domain, we get a common difference of 2 throughout. Unlike the first one where we got 1. So it means that it's not always that you get a difference of 1. Okay. So you can have a difference of 2, 3, 4, 5, whatever value, but the difference must happen to be constant, like the same difference. When we look at the codomain 2, we have a common difference of 4. So there's that constant difference in there. I hope we understand. Can we guess the rule for
Yep.
this particular mapping? Can anyone guess? Okay, Olivia.
Step one will be equal to 2x minus 1.
2x minus 1. Okay, that's a guess. And then I see Amankwa saying x plus 4. And Jelisa also saying 2x, okay, plus 4. Okay, that's fine. So we shall look at the approach, how to go about it and get a final result. Okay, what about this? Is it a linear mapping as well? Empress,
Yes, it is not.
it is not. Why?
Because the consecutive numbers in the codomain, the difference is not constant.
Okay. Do we agree with her? Okay, I see Rahina too here. Rahina too, what's the difference between the codomain?
Please, I don't agree with what she said.
Okay, that's good.
There's a difference between the code.
Uh-huh.
The difference between the codomain is the square of the numbers.
Okay.
That's what I'm giving.
Who wants to respond to that?
Therefore, it is a linear mapping.
Okay. Who wants to respond to that? Okay, Rahina too, your mic is on. Go ahead and speak.
Okay, so I think the codomain,
Yes.
it's the difference is it's being multiplied by 2 because 2 times 2 equals 4, 4 times 2 equals 8, and then 8 times 2 equals 16.
Oh, okay. So you are more or less like telling us a rule that is generating the various
Yeah.
members in the codomain. Okay. And okay, so let's continue the discussion with regard to the question that was raised. Um, if your hand is up.
Yes, please.
Okay, go ahead.
So this is not a linear mapping because the main idea of a linear mapping is for the element in both the domain and codomain to be constant. So the difference for x is 1, but then the difference for y you can't say, oh, maybe it's 2 or maybe it's 4 because they are not. It's not constant. Because 2 to 4 is 2, 4 to 8 is 4. So it's a kind of mapping, but it's not a linear mapping.
I see Rahina two's hand up.
Yeah, I agree with her because it's not a linear mapping because the difference in the codomain is not constant.
Let's have Caleb. Caleb, what do you think?
I also think it's not a linear map.
Okay, why?
It's because there's no constant or direct rule that links the domain and codomain directly.
Okay, so you are talking of the rule.
Yes.
Okay, okay, very well. So you've all done well with your contribution. So what I want you to pay attention to is that in order to determine whether a mapping is linear, we are considering two things. One, the difference between the members in the domain. We are checking to see if that is constant. So what does that mean? It means that we are taking this and that. When we subtract, that will be 2 minus 1. We end up getting a 1, right? And then the difference between that, that is 3 and 2, we end up getting a 1. Then the difference between that, 4 and 3, we end up getting a 1. So we can see the difference for the domain is constant, the same value. But for this particular codomain, when we take the difference between these two, that is 4 and 2, we have 4 minus 2, we end up getting a 2. And then the difference between 4 and 8, that is 8 minus 4, we end up getting a 4. I hope you agree. Okay. When we take that of 8 and 16, the difference would be 8 as well. So in this case, you see that the difference between these consecutive members is not the same, it's not constant. So we can't say this mapping is linear. It may be something else, but it will not, when you plot the values of the x and y, if you take the x and y and you plot it. I hope you remember doing this in the basic school. You were given mappings and you plot them. When you plot this particular one, you will not get a straight line because the difference is not common, or it's not a common difference. Yeah, constant. It's not constant. Unlike the previous one, let me go to one of the previous one. This particular one, when we do the difference between 0 and 2, we get a 2. The difference between 2 and 4, we get a 2, and it continues. You see that you'll be getting 2 throughout. So this particular one is constant here. And over here, the difference here is 4. Over here, the difference here is 4 as well. And then the difference here is 4 as well. I hope you understand. Okay. So what I was saying was the difference between them must be a constant. So we should be able to use that to determine whether a mapping is linear or not. Okay, so you remember in the basic school, the equation of a line. We learned the equation of a line, which happens to be y equal to mx plus c. So in order to generate the rule for a linear mapping, once you are able to find out that the mapping is linear by checking the consecutive values for the domain and the codomain, you can then apply the rule, or let me say the formula of a straight line. Okay, so you can use y equal to mx plus c to generate the rule for that mapping, because the mapping itself is behaving like a straight line when you plot it. So you can use that. So of course, for every line, we can determine the gradient and we can determine the constant c. In some books, you have the equation of a line written as y equal to ax plus b. So for those of you who learned that, it's the same thing. It means that the coefficient of the x becomes our gradient, right? So in order to find the gradient, we take that constant difference of the codomain and divide that by the constant difference of the domain, which is the same as this one we're doing in the basic school. When we're finding the gradient of a line, this is the formula we used. That's y2 minus y1, all divided by x2 minus x1. So the y2 minus y1, that's the constant difference of the codomain. And the x2 minus x1, that is the constant difference of the domain. So that will give us the gradient of the line. If you use this formula, it means that will give you the A. Okay. So for the sake of time and those who will be going for other classes, I would like to end the lesson here so that others can go for other classes as well. The next time we meet, we would continue from where we left off. Before we leave, any question? Okay, if no question, let's share briefly. Okay, Napari.
Please, please, is this the rule for linear?
Mapping, yes, for linear mapping. So let's share briefly what we have learned before we leave. Napura, your hand is up again. Napari, sorry, I'm pronouncing your name wrongly.
Sir, please, what's the rule for the previous thing?
The previous ones, we were interested in looking at what makes them a linear mapping. So in our next lesson, we shall look at how to apply the rule, okay, to obtain the what do you call it? The actual rule for a particular mapping. I wish we had done that today, but time is not on our side. But we are looking at the fact that what makes these mappings linear. Once we are able to establish that, because trust me, there are several type of mappings, different types of mappings, but we need something to identify them. And one thing we can use to identify them is the difference between the consecutive members. So far as we are able to establish that the mapping is linear, then we can go ahead and apply the rule. That is the equation of a straight line. I hope you understand. So we shall do that in the next meeting. Look at it. But then I would entreat all of you to go and find out how to do that. Try to work some examples. You can share with us in our next meeting. Before we leave, what are some of the things learned today? Let's quickly talk about that and then we'll end our lesson. Okay, Blessing.
Okay, so I've learned how to determine whether a mapping is a linear mapping
Okay, that's great. So how do you determine that?
by checking whether the difference is constant.
Okay. Caleb.
I've learned of the previous, or at least two types of functions, which are one-to-one function and many-to-one function. And the difference being that one-to-one functions have one domain linking to only one codomain.
Okay, so I see from here Olivia Benson saying mapping and its type. Elisha, one-to-one relation, Sapon relations, and mappings. Okay, I learned mapping by Nina. Okay, so let me see if there's any hands raised again. Okay, no hands is raised. Thank you all very much for joining today's class. I hope that you really enjoyed it. And God willing, in our next meeting, I think on the timetable, when is the next meeting?